Hello everyone and welcome to a new video. Actually, I created a new series called Firmware. As I mainly work with embedded devices, testing firmware is kind of key part of my usual tasks. In this series, I have several ideas to share, but I will start by focusing on extracting secrets from firmware. For this reason, I have designed exercises based on common industry problems. While these issues are straightforward, you would be surprised how often I have encountered them in practice. Before we start, let's a little bit introduction about firmware. What is firmware? Actually, firmware is software, usually coded in C or C++, and compiled for particular hardware. Then it is permanently stored on the device non-volatile memory such as the NAND flash or the EEPROM. The firmware manages the device hardware and of course enable the functionality specific to the device purpose, whether this device router, camera or microwave or any other IoT devices. The act of extracting the firmware image from a device is known as the dumping the firmware. I may create a video on how to extract firmware from embedded system devices, but this is for another video. For various reasons, some firmware contains secrets like passwords, and these secrets can be stored in different forms. It could be plaintext password, hashed password, encoded password, or even password stored in external library. We will cover external libraries in another video since they require dynamic analysis of the firmware, and I need to introduce the concept of dynamic linker. So in this video we will focus on the other three options. So before we begin, I wrote a simple C program that asks the user for a password, and it indicates whether the supplied password is correct or incorrect. Then I compiled this code on our target machine, the Ubuntu, and I used GCC version 5.4. And of course I created different firmware versions for each test case, and we will attempt on to find this password on our attacker machine running Kali Linux as usual. So for now, assume that somehow the attacker has obtained the device firmware and it's ready for analysis. So let's start with the first exercise. So when you see here I have three different firmware. If I run file on the BT, you would see it's an ELF file, 64-bit architecture. If I execute the firmware, it asks for a password. Whatever I provided, it would say no, password is incorrect, try again. This is the simplest exercise. You only need to know two commands: the strings command and rabin2. Actually, it's part of Radari 2. If you are not familiar, Radari is a framework for reverse engineering and analyzing binaries. So let's try it. Let's try first the strings command -n6. -n6 is the minimum number of character that strings will present or print on the screen. Then the firmware, I will take plain text. You see here strings showed a lot of strings inside the binary, and we have seen this before. No, password is incorrect, try again, and of course what come to our attention is the password 123 here. So the password is stored in plain text. Before we run the program again, let's try Radari bind 2 -zz, and again the same firmware. The difference is that Radari binary 2 will show the sections of the binary. You can see here that our password is here and it is stored in the read only data section. So now we have the password. If I run the software again, I provided the password and you see you have found the password. So it's very simple. Now let's try the second exercise. This is the password stored as a hash value. Again, I will run the same command, so strings -n6, but this time on the firmware hash. And you see here I don't have the password as a plain text, but what I have a hash value here. Once you get the hash value, the first thing we need to do is to identify the hash type. So you can do it in multiple way. One of them is hash identifier, and then I provide the value, and it tells me it most probably SHA-256. There are many tools to crack the hash. Hash the cat or join the Reaper. In this video I will use hashcat to crack the hash value. This is the general command for hashcat. -m, it takes the mod number. This is related to the hash type. Then we have the hash value, then a path to the word list. In this case I will use RockU, which is a well-known word list. It comes pre-installed in Kali. Regarding the mod number, we can get it from hashcat from this link. I have it already open here. So if I search for SHA-256, actually this is our hash. There is no salt here, so 1400. This is the hash mod number. So now I have all the information I need. I could simply run hashcat -m 1400. Then I provide the hash value and then path to the word list and RockU. That might take some time. It takes some time, and as you can see here, the password is recovered. So hashcat was able to break or crack the hash. Let's continue to our third example. Now in this case we have the password stored as encoded value. So again, let's run for this time Radari binary 2 -zz, and I will take the encoded and here let's look again. There is no plaintext password, but what comes to our attention is this value here. One tool we can use because we need to identify what type of encoding, so we can use CyberChef for that. And if I copy it here and let's use the magic for now, you would see it says it's base 64 and it's already recovered the password, so that's good. What we can do also is echo and the value here, then base 64 decode, and you will see the password is here again. So we recovered the password in this case. So in conclusion, before diving into deep analysis of any firmware, run these initial commands to inspect the strings inside this firmware. This usually provide you with kind of overview about what is hidden or what's stored inside the firmware. For instance, recently I have shared one vulnerability, uh, as you see here, CVE, it's 2024, and it's on Siemens, so it was found in Siemens PLC. And if I scroll down here, you will see it's hard coded root password. So even now we are 2024, and you still find some devices that contain a hard-coded password within them. If you want to look on the C code, so this is the C code for the plaintext password. It's very simple. Ask the user for the password, use scanf in order to receive the supplied password, and here we have a comparison between if the password is correct or not, and based on that it will print to the screen either it's correct or incorrect. It's almost the same for the hashed value. Of course, the main difference is I added the function calculate SHA-256, and I used the library from OpenSSL in order to calculate the hash. You see here is the hash value. Once the password received from the user, the hash will be calculated, and then a comparison again will happen, and based on that you will get the result. For the third exercise, the encoded one, again it's very similar. Here we have a function which will do base 64 decoding. So the password was received by the user, and this value here will be decoded. If you notice, I used the same command here, but I embedded it inside the C code, and the comparison happened again, the result returned to the user. So this is the C code for all the three exercises, and this is how you extract firmware from secrets from firmware. I hope you enjoyed and learned something from this video. I see you in the next video. Bye bye.